In this video, we're going to look at how you can use the law of sines to find missing sides and angles for oblique triangles. And oblique just means non-right triangles. So these are triangles that do not have a right angle in them. So when you draw your triangles, you're going to label your vertices of the triangle with capital letters, and then you're going to label your sides of the triangle with lowercase letters that match the uppercase letter directly across the triangle. So if I put a capital A here, then directly across the triangle, I would label that side with a lowercase a. And the same for capital B, directly across lowercase b, capital C for the angle, directly across lowercase c for the side. So the law of sines says that the ratio of side A over sine angle A is the same as side B over sine angle B is the same as side C over sine angle C. And these can be used interchangeably. They don't have to be in this order. And so you can set up these proportions. You can use fraction A with fraction C, fraction B with C, vice versa. Okay, so the law of sines works with three types of triangles. If you are given angle, angle, side. If you are given angle, side, angle. And if you are given side, side angle. So in this video, we're going to focus on an angle, angle, side example and an angle, side, angle example. In these two examples, you're guaranteed to have exactly one triangle. In the side, side angle example, it's called an ambiguous case. You could have two triangles, you could have one triangle, or you could have no triangle. So I'm going to do that one in a separate video because it takes a little bit longer to explain. Okay, so let's look at our first example. I'm going to give you side B as 27.4 centimeters, angle B as 28.7 degrees, and angle C as 102.3 degrees. So it helps sometimes to draw these triangles out just so you can see exactly what you're dealing with. And so you can label your vertices ABC however you want to, but since angle C is obtuse, I would probably put angle C here because that looks like the most obtuse angle. So we have 102.3 degrees there. And then we can put our A and B at the other two vertices. And so angle B is 28.7. And then little b has to be directly across from big B. So little b is over here, 27.4 centimeters. Okay, so you have to decide what type of triangle you're dealing with whenever you're given this information to make sure it is a law of sines problem. And so you know that you're given two angles and a side, and the side is not directly between the two angles, so this is an angle, angle, side problem. Okay, so you can set up your law of sines proportion with what you know so far. Right now, we don't have anything at all to do with our A's. We don't have little a or big A, so we're just working with these two fractions right here. We do have little b, 27.4, over sine of big B, which is 28.7. We don't know little c. We don't know side C. But we do have angle C, which is 102.3 degrees. So to solve this proportion, we are going to cross multiply. So we have 27.4 times the sine of 102.3 degrees equals C times the sine of 28.7 degrees. And so our objective here is to get the little c by itself. So we're going to divide both sides by sine of 28.7. Okay, so on this side, those two will cancel out, and you'll have little c equals whatever you get when you type that in your calculator. So make sure that you're in degree mode when you type that in. And so here we have 27.4 times the sine of 102.3. And then we're going to divide that by sine of 28.7, and it gives us 55.7. And for right now, I'm just going to round to the nearest tenth for our final answers. Make sure when you're doing this on an assignment that you follow your rounding instructions. For right now, we've got 55.7 centimeters. And I'm sticking with the nearest tenth because my original numbers were given to the nearest tenth. So I'm going to give my answers in that same form. So side C, 55.7. Okay, so now what we need to find is angle A and then little side A. We can easily find angle A because we know the other two angles in the triangle, and we know that all the angles in a triangle have to sum to 180 degrees. So we can do 180 degrees minus the two angles that we already know, minus 102.3 and minus 28.7. So we can subtract that. 180 minus 102.3 minus 28.7 gives us 49 degrees for angle A. Okay, so the measure of angle A, 49 degrees. And the last thing that we need to find is side A. Okay, so now that we have angle A, we can use this fraction now to cross multiply with one of these two fractions. And typically you want to cross multiply with the fraction that had the most original information given. And so we were given the most information with our B's. So we want to cross multiply with that one. If we cross multiplied with the C fraction, we're using a rounded answer right here. So our answers will be off a little bit more. So we want to use as much original information as possible, which was our B fraction. Okay, so fraction B was the 27.4 divided by sine 28.7. And then we're going to cross multiply that with our A fraction. So little a divided by sine 49. Okay, cross multiply those. 27.4 times the sine of 49 degrees is going to equal A times the sine of 28.7 divide by sine 28.7. Those are going to cancel. Divide by sine 28.7 over here. Okay, so you're going to type in 27.4 times the sine of 49, and then divide that by the sine of 28.7, and you get 43.1 centimeters for side A. And so you have found all three missing pieces of the triangle. And again, that was an angle side example. Okay. Let's try another example. This time we're going to go with angle A, 43 degrees, angle B, 98 degrees, and side C, 22 inches. Okay, so if we want to draw this out, and label our vertices ABC, we know that angle A is 43 degrees, angle B, 98 degrees. That's our obtuse angle there, greater than 90. And then side C is 22. Side C has to be directly across from angle C. So side C would be right here, 22 inches. Okay, in this problem, you have two angles again, but this time the side that you're given is directly between the two angles. So this is an angle side angle triangle. Angle side angle. Okay, so this time if you set up the law of sines, we actually have something from each fraction. We have something from our A fraction, B fraction, and C fraction. So it looks like this. Side A over sine 43 side B over sine 98, and then 22 for side C over sine angle C, which we don't know. So when you look at this, we don't have any one of our fractions that's complete to cross multiply with. So we're going to have to complete one of our fractions before we can start. And we're going to do that by finding angle C right here. Remember that we can subtract from 180 using the two angles that we already know and complete this fraction right here so that we'll have a fraction that we can cross multiply with. All right, so we want to do 180 degrees minus the 43 and the 98 that we already have to find angle C. So 180 minus 43 minus 98 gives us 39 degrees. So the measure of angle C is 39 degrees. And that's going to go right there. So we can replace that with a 39. Now we have at least one complete fraction that we can cross multiply with. And from here, it doesn't matter which one you find first, whether you find A or B first. It doesn't really matter. So I'm going to go ahead and I'm going to cross multiply these two right here that are next to each other and go ahead and find side B. So if I do that, it's going to be B times sine 39, B times sine 39 degrees equals 22 times sine 98. Okay, so I need to get B by itself. All right, in order to do that, I need to divide by sine 39. Those are going to cancel. Okay, so you're going to type in 22 sine 98 and then divide by sine 39. And I'm getting 34.6 as that side B. Okay, now you're going to cross multiply again to get side A. I wouldn't cross multiply with fraction B because we have a rounded answer in fraction B, which means our answer could be off a little bit from using a rounded answer. So I would keep multiplying with fraction C since those are not rounded. So now I'm going to cross multiply fraction A with fraction C. So kind of ignore this fraction in the middle here, multiplying side A by sine 39. So we have A times sine 39 degrees equals 22 times sine 43. Trying to get A by itself, so we're going to divide by sine 39. Those cancel. All right, so we're typing in 22 sine 43 and divide by sine 39. It's giving us 23.8. 23.8 inches. And so you found all three missing parts. You found the missing angle C, missing sides A and B.